Hello there, sixth graders. So today we're going to continue talking about rates and ratios. So let's take a look at example 1. So we're going to write each of these ratios as a rate. So remember that when we're writing something as a rate, we're writing with, our ratio has one of the numbers is 1. Okay? So let's take a look here. So we have the ratio of miles to the number of hours is 434 to 7. So our kind of ratio that we're starting with is 434 to 7. So our rate, we need our hours to be 0. So in order to figure that out, we are going to divide each of those numbers by 7. So we're going to divide 434 by 7. 7 can't go into 4, so we put a 0 at the top. 7 can go into 43 6 times. So our 6 is going to go up to the top. We know that 6 times 7 is 42. We subtract and get 1, bring down our 4. 7 can go into 14 2 times, which we know is 14. We subtract and get 0. So our rate is going to be 62 miles per hour. So in 1 hour at this rate, you'll travel 62 miles. Let's take a look at B. So B says the ratio of the number of laps to the number of minutes is 5 to 4. So the ratio that we're starting with is 5 to 4. So 5 laps in 4 minutes. And if we want to get to our unit rate, or to our rate, we want to know how many laps in 1 minute. So we're going to divide both of these by 4. So what that's going to look like, we can almost think of it as 5 laps over 4 minutes, right? Because our fractions are just a division problem. So what this will end up being, right, we divide our 4 by 4 and get 1, and 5 by 4, and we're going to get a fraction. So this is going to equal 5/4 laps per minute. We can kind of reduce that down to, so you could also say 1 1/4 laps per minute. So this is a little bit of review of what we talked about yesterday with rates. So let's take a look at our next part. So we have these 3 kind of flow charts to show our ratio, our unit rate, and our rate. So our ratio, and we're looking at B, so we're looking at the number of laps to the number of minutes. So we're looking at that last question that we just talked about. So our ratio is the original ratio from our problem, which is 5 to 4. Our unit rate is, in this case, how many laps in 1 minute. So that would be 5/4, or 5 over 4. And our rate is exactly what we wrote for B, 5/4 laps per minute. Remember when we see that slash mark, it means per, right? Like miles per hour, laps per minute. Let's take a look at our next page. So our next page for B, we have that same setup again, but this time we have a rate of 6 feet per second. So our unit rate is going to be 6. We're going to kind of work backwards here. So our unit rate is 6. Our ratio, we have a bunch of options, right? We can say something as simple as 6 to 1, or we could make it a little bit more complicated, say something like 12 to 2, or we could say 60 to 10, any equivalent ratio, as long as it's equivalent to 6 to 1. All right, let's take a look at example 3. So example 3, we're looking at Dave, who can clean pools at a constant rate of 3/5 pools per hour. So he can clean about 3/5 of a pool in an hour. So our ratio, we're taking that fraction, kind of like we did for B, how we turned our ratio into a fraction. We're going to go backwards here to get to our ratio. So the number of pools to the number of hours, our ratio is going to be 3 to 5. So that fraction just gets turned back into a ratio, right? 3 pools in 5 hours. So that means that in 10 hours, we want to know how many pools Dave could clean. So we could do this with a tape diagram, or we can do it by multiplying. So if Dave can clean 3 pools in 5 hours, in 10 hours, to get from 5 to 10, we're multiplying by 2. So we'll multiply 3 times 2. He can clean 6 pools. And then if we want to see how long it takes for Dave to clean 15 pools, so our ratio is going to change 15 to something. To get from 3 to 15, we're multiplying times 5. So we're going to multiply 5 times 5 as well to get to our second part of our ratio. And 5 times 5 gives us 25. So that means to clean 15 pools, it takes Dave 25 hours. Let's look at number 4. So I want you to take a second. I want you to try number 4 on your own. And then you can pop back on to check your answer. Or if you get stuck, you can pop in and get yourself kind of unstuck. All right, so Emmeline can type at a constant rate of 1/4 pages per minute. So what is the ratio of number of pages to the number of minutes? So we're going to turn that fraction back into a ratio of 1 to 4. Emmeline has to type a 5-page article but only has 18 minutes until she reaches the deadline. Does Emmeline have enough time to type her article? Well, if it takes her 4 minutes to type 1 page, we need to see how long it's going to take her to type 5 pages. So to get from 1 to 5, we're multiplying by 5. So if we multiply 4 times 5, we get 20. So in order for Emmeline to type 5 pages, she needs 20 minutes. So she will not make her deadline. So we can say no, she needs 20 minutes. Then our next question, Emmeline has to type a 7-page article. How much time will that take her? So again, we're going to 7. So our 1 is becoming a 7. To get from 1 to 7, we multiply by 7. So then we're going to multiply our minutes by 7. So our 4 times 7, which gives us 28. So that means it'll take her 28 minutes. I want you to go ahead and pause again, and I want you to look at number 5 on your own. You can pop back on to check your answer, or if you get stuck. All right, let's take a look at 5. So it says, Xavier can swim at a constant rate of 5/3 meters per second. What is the ratio of the number of meters to the number of seconds? 5 meters to 3 seconds. So we can find these using different methods. We can use a tape diagram, we can use those double number lines, we can use a ratio table, whatever works best, or you can just multiply like we have been. Xavier is trying to qualify for the national swim meet. To qualify, he must complete a 100-meter race in 55 seconds. Will Xavier be able to qualify? Why or why not? So if we know that he can swim 5 meters in 3 seconds, we need to know how long it's going to take him to swim 100 meters. So what do we have to multiply 5 by to get to 100? So we have to multiply 5 times 20 to get to 100. So 5 times 20 gives us 100. And then 3 times 20 gives us 60 minutes. So, no, Xavier won't qualify. because it will take him 60 minutes to swim 60 seconds, not 60 minutes, 60 seconds to swim the 100 meters. Part C, Xavier is also attempting to qualify for the same meet in the 200-meter event. To qualify, he has to complete the race in 130 seconds. Will Xavier be able to qualify for this race? Why or why not? So now we're going to double our ratio. So to get from 100 to 200, we have to multiply times 2. So we'll multiply 60 times 2 to get 120 seconds. So yes, Xavier will qualify because it only takes him 120 seconds to swim 200 meters. So he'll qualify for that event. Let's take a look at our last problem. You can go ahead and pause here and work on this one on your own, then pop back in to check your answer. All right, so number 6 says the corner store sells apples at the rate of $1 or $1.25 or $1.25 per apple. So what is the ratio of the amount of dollars to the number of apples? So that ratio would be kind of just like it says, 1.25 or 1 and 25 hundredths to 1. So our next part says Akia is only able to spend $10 on apples. How many apples can she buy? So if she can only spend $10, we need to figure out how much or how many apples she's able to afford. So we have $1.25. Well, I know that that's more than $1, right? Our rate of 1.25 is going to equal $1.25. So I know that that's more than $1. So I know that she won't be able to buy 10 apples, right? Because if she were able to buy 10 apples, they could only be $1. So let's try multiplying. Let's try bringing that down a little bit. We'll try multiplying by 8. So we'll take 1.25 and multiply times 8. 8 times 5 gives us 40. 8 times 2 gives us 16, plus 2 gives us 20. And 8 times 1 gives us 8, plus 2 gives us 10. We have 2 numerals after our decimal point. So our decimal point is going to have 2 zeros behind it. So that means that she's spending exactly $10. Perfect. That's how much she has. So she can buy 8 apples. Now we're going to do kind of the same thing. So Christian has $6 in his wallet and wants to spend it on apples. How many apples can Christian buy? Well, we know that 8 apples is going to be equal to $10. So we know that if he only has $6, he's going to need to buy less than 8 apples. So let's bring it down a little bit more. So let's try times 6. So we'll have $1.25 times 6. 6 times 5 gives us 30. 3 times 2 gives us 12, plus 3 gives us 15. 6 times 1 gives us 6, plus 1 more gives us 7, and our decimal point. So 6 apples cost him $7.50. So that's too much. He can't buy 6 apples. So let's try less than that. Let's try $1.25 times 4 apples. 4 times 5 gives us 20. 4 times 2 gives us 8, plus 2 more gives us 10. 4 times 1 gives us 4, plus 1 more gives us 5, and our decimal point. So we have $5. So that's perfect. So that's less than what he has. He has $6 in his wallet. 4 apples will cost him $5. So if he bought, I can tell by looking at this, if he bought one more apple, if he bought 5 apples, $5 plus $1.25 is going to cost him $6.25. He doesn't have enough for that. So he can only buy 4 apples. Alrighty. All right, so let's take a look really quick at your independent practice. you have 2 questions here. You have one about a commercial plane reaching altitude, and then you have one about snowstorms in Denver, Colorado. If you have any questions, please let Miss Sally know. She is available and she is happy to help. Before I forget, let me give you your secret word of the day. And I know that our secret word today is one that we've had for ELA, before, but that's okay since it was for ELA. So our word today is snowman. Just make sure you have snowman written somewhere on your paper. Alrighty, I hope you all have a fantastic rest of your day, and I will see you next week. Adios, 6th